Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Actually, in part 14, I have explained the chemical reactions involved in the properties of alkyne. And this is the short revision of reaction in organic chemistry. We will see here the reaction of alkyne, especially in the properties, that is called chemical properties of alkyne. I have finished most of the reaction, though some reactions are left. So you can say that part 14 continued. When part 14 you will see, you can see also this one, that is a part of the 14. And now first you will see after addition reaction is a that means addition reaction is a big part, and here you can see so many types of addition reaction. And now we will see oxidation. What is meant by oxidation? Generally we know. Oxidation means addition of oxygen. Oxidation means removal of hydrogen. Oxidation means removal of electron also, loss of electron also. Now we will see how oxygen involved here. That is called bonding. Bonding by which? With the help of oxygen. You know something is bonding mean that oxygen is there. That means bonding in air means the oxygen present in air which will help to bond that compound, to bond that alkyne compound. Now see here combustion. Combustion means bonding. So bond in air or oxygen produce carbon dioxide and water. Directly you supply oxygen and that you will bond it, or otherwise you depend on the oxygen that present in air, that also help for the bonding of the alkyne. Now here what we see, let us simple example ethine. You know this is ethine. Ethine when bond, it gives carbon dioxide and water. That means oxygen should be required either from the air or you can supply oxygen more, then this is the same. Now propyne, the second compound propyne. Propyne you can see here bond, it gives same carbon dioxide and water. That means any alkyne compound, the smaller one, bigger one or branch one, that means it gives only carbon dioxide and water. Remember, any compound in alkyne that gives carbon dioxide and water. Then second part, oxidation with alkaline KMnO4, where you are supplying oxygen in atomic form. That means here alkaline KMnO4 is called Bayer's reagent. What is that called? Bayer's reagent. Now when you take Bayer's reagent, it will give, what it will give? It will supply oxygen from the Bayer's reagent. So only you write KMnO4 plus water in the presence of alkaline, that is called Bayer's reagent, and here it gives, now this carbon becomes to double bond here also double bond, and this side OH. Now see, there is no oxygen here, but here 1, 2, 3 oxygen are there in the form of, this is acid form. See here, this is the COOH. You can write COOH or you can write C double bond OH. Both are having same meaning, that is acid, carboxylic acid. So what happened here, this is known as 2-oxo because it's 2 position. 1 position, this is number 1 and this is number 2. 1 position that is containing acid part, acid group, carboxylic acid group, where 2 content that is oxo group. This is called oxo. When there is no other functional group, then it is called keto group, but some functional important group is there which count first, then it is known as oxo. So 1 position acid and second position oxo. So what is the name? 2-oxo-propanoic acid, because this acid contains only 3 carbon, which means propanoic acid, 2 position oxo group. So what is the name? 2-oxo-propanoic acid, and commonly it is very famous, that is pyruvic acid. Pyruvic acid, that is very much helpful in biochemistry. So this is 2-oxo-propanoic acid. Then we will see other process of oxidation also. When oxidation takes place with help of Bayer's reagent, that is alkaline KMnO4 with water, then what happens? Different products are formed according to the temperature. You should see what is the temperature. So here you should remember the temperature. Now propyne And pyruvic acid, when you will get the same condition with ordinary temperature, but here it is 373 to 383 Kelvin, you will get only ethanoic acid. When ordinary temperature, you will get here pyruvic acid, but temperature when this one, you will get ethanoic acid. Similarly, if you take a but to wine, same alkaline came for here also temperature low. When you see both reactions are same, only temperature is different. See here, this is butane, but to wine, this is also but to wine, and temperature 290 to 300 Kelvin. Here it gives butane 2,3 dione. What is 2,3 dione? Dione means 2 keto group. Position 2 and 3. This is 2 and this is 3. And it is butane 2,3 dione. Now, if you change the temperature, that means here, if you take that temperature 373 to 383, and the product is 2 acetic acid. That can you compare all the reaction? When temperature high, this alkyne gives generally acetic acid, and temperature is low, the compound is different. So, if you take ethyne, that is very important, where you will get only oxalic acid. This is called oxalic acid. So, with acetylene or ethyne, oxalic acid. With but to wine, the temperature high, then it gives acetic acid. If temperature is low, but this temperature, then it gives 2,3 dione. And here also propane gives ethanoic acid at high temperature, and low temperature it gives pyruvic acid. Now we will see ozonolysis. Next reaction we will see addition of ozone. What is addition of ozone? The process is called ozonolysis. So here, first when your ozone is added, and the product is called ozonide. Ozonide, when treated with zinc and water, it gives diketone. Diketone means 2CO group. So, on zinc and water, it gives diketone. So, for simple one, ethyne. Ethyne when treated with ozone, here ethyne, when treated with ozone, it gives ozonide. See here, the C and H remain as it is. That carbon, oxygen, 3 oxygens are used, and that is ozonide. When react to zinc and water, H is there, the C is there, double bond, C double bond H, and that is what? Glyoxal. So, here again you see this is called propyne. That means propyne when react with ozone, propyne ozonide. This is propyne ozonide, CH3 remain as it is. Here the 3 oxygen is remain, and this side is CH. So easy to know, easy to remember. Now zinc water it gives C double bond 2CO double bond is there. What is the name? Now this is as aldehyde group. This act as a aldehyde group, and what is that is known as null. And here 2 position. This is 1. This is 2. 2 position there is oxo, and this is 3 carbon propanol. 2 oxopropanol. How it is 2 oxopropanol? In 1 position CHO group and 2 position that is oxo group. That is why 2 oxopropanol. Then come to but to wine O3. Then what is this? This is also called butane, but to wine ozonide. Or the ozonide again reactive. It react with water and zinc. Then what happens? It gives, what is that? CH3 remain as it is. The C becomes to double bond. The C becomes double bond CH3. And what is the number of carbon atoms? 4. 4 means but. And there are 2 keto group dione. What are the position of dione or keto group? 2 and 3. So name is butane 2,3 dione, and this the oxygen is there, it gives zinc oxide, and that will remain as a byproduct. So here it is known as butane 2,3 dione. Again I want to see ozonolysis is very easy for alkyne specially, and now CH triple bond, sorry 2 carbon triple bond. That is why here like this you copy it, CH, and this is 3 oxygen, and now this glyoxal because here as it is, but here only double bond. Similarly, propyne 3 carbon, and when as it is C after ozone addition C CH3, this side CH and oxygen are added to make the valency 2 of oxygen. Zinc and water, again you see this is the aldehyde part, and here 2 oxopropanol, and here but2-wine O3 it gives ozonide, water and zinc it gives butane 2,3-dione, butane 2,3-dione. This is called ozonolysis. The phenomenon is called ozonolysis, and the reaction, that is addition of ozone, that is also one type of addition reaction, but the process is different. That is why it is not undergoing, it is not there in addition reaction, because the process is ozonolysis, especially it is known as ozonolysis. Then you will see the other reaction, that is polymerization and polymerization. Now the reaction we will see polymerization. Polymerization of alkyne. Then question is, what is polymerization? Polymerization, the chapter is very important in 12th class, especially one chapter is there in 12th class. Now you only here you know in shortly what is polymerization. A large number of small molecules join. A large number of small molecules join to form a large molecule. That means just like you see number of flowers are there. If that means number of large number of flowers. If you make one garland, and that is called one garland, that is a large molecule, that is called polymer. And the small molecules are called monomer. That means a single flower is called monomer. When 102,000 flowers join to give a large number of one garland, then that is called large molecule. One large garland, that is called polymer, and small molecule, that is small number of a large number of flowers, that is called monomer. Are you clear? If you think about a garland and the flower each that is known as monomer, and the garland that is known as polymer, and the process, the phenomenon, that is called polymerization. Are you clear? Polymer, monomer, polymerization, that will clear in 12th class. Now let it be acetylene or ethyne, then it gives the condition condition is different. A particular condition it gives polyethyne, polyacetylene. Then come to cyclic polymerization. Cyclic polymerization means here it will give a closed structure. The ethanol passing, the condition see here, red hot iron tube at 73 Kelvin undergoes cyclic polymerization. 873 Kelvin iron hot tube, and here it gives, when you pass this one over 3 molecules of acetylene, gives 1 molecule of benzene. See, everywhere there is CH there. Everywhere CH is there. So what happened? One is polymerization, one is linear polymerization, other one is cyclic polymerization. A large number of small molecules, that is called monomers, each one is called monomer, and here small molecule, don't write plural, otherwise that may be confused. Small molecule is called monomer, a large molecule which is formed, and that is called polymer. And now the phenomenon is called polymerization. Example, ethyne, that is polyethyne. See here, this CH is a large number joined, and it's a very large, maybe 1 lakh, maybe above that also. And cyclic polymerization will form a cycle 1 closed ring 1, and 3 molecules of acetylene passed over red hot tube, and temperature is 873 Kelvin in this benzene. I hope it is clear to you, and there are so many important reactions in alkyne, and hope you will subscribe my channel B.L. Das, short and sweet in chemistry, and thanks for watching my video. Again, thanks to all.